Hi everyone, welcome back to electromagnetism. Now, we started out the chapter with introducing to you the right hand grip rule, where the thumb follows the direction of the current and the four fingers follow the direction of the magnetic field. And then we went on to explore the interaction between two magnetic fields of two different currents, whether they are in the same direction or whether they are in the opposite direction. Now we are going to push ahead with more analysis, and what I've shown you here on the screen here is the current flowing through the red wire and is put in between a magnetic field, a north and a south pole. Put in a magnetic field, sorry, not in between. Put inside a magnetic field between two poles, a north and a south pole. So from here, we can see that the direction of magnetic field is very clear for north and south. But the magnetic field around the wire is, well, can be clockwise or anti-clockwise, depend on where you're looking at from. Now, one is a circular magnetic field and one is in a linear magnetic field. So how do these two fields interact? First of all, let's recap here. Let's get an idea of what this diagram is all about. The circuit is closed, the current flows. This red wire is actually suspended with one end pivoted at the top and the other end loosely hung in a pool of mercury. Okay, loosely hung in a pool of mercury. You want to put a pool of mercury there because this red wire is loosely hung. It's not connected. And the mercury is actually a liquid. It allows electric current to flow. So that means this red wire is free to swing around. Right, this is free to swing around. So when the current is on, when the current is switched on, current will flow through the red wire. There will be a magnetic field around the red wire, and there's also a magnetic field from north to south pole. How do these two magnetic fields interact? Now, if you want to see at a three-dimensional level, it's going to be very tedious. And over here, we're going to simplify it for you. Now, you note the position of the eye. So we are going to see this whole structure from the top view. You're going to see this whole structure from the top view and simplify our analysis. Now, from the top view, the current flows into the plane. And on one side, you have the North Pole. On one side, you have the North Pole, and on the other side, you have the South Pole. So, just for the purpose of explaining to you how this works, I'm not going to complete this diagram with a lot of magnetic field lines. I just want to draw maybe one or two simple field lines to explain to you how it works. So with the current flowing into the plane, using right hand grip rule, this will be the direction of the magnetic field. How about the magnetic field from north to south? Note that the top of this magnetic field is from left to right. So from north to south, it will be drawn this way, always in the same direction as the magnetic field. Right? We draw the top because they are in the same direction. We don't draw the bottom because the field lines have been cancelled out. Right, so I'll just draw one for the sake of illustration. It's north to south. You realize these two, they cancel each other out, right? So we don't draw a bottom, we just draw the top. And recall in the earlier example, we learned that when there are more magnetic field lines in one region, the magnetic force is greater. Okay, so from here, we can deduce that there are more, we'll label this region X and this region Y. There are more magnetic field lines in X than Y. Therefore, magnetic strength at X is greater than magnetic strength at Y. So the wire will move downwards. So let's go back to this diagram. If I want to map this, if I were to map my 2D drawing to this 3D drawing, okay, this region is green, this region is purple. Alright, so I will say that over here, the magnetic strength is greater. Sorry, I think I'll label this X and Y to give more clarity. So this is actually X and this is actually Y. So the magnetic strength is actually greater at X. Therefore, my red wire will deflect here. You swing in this direction. Right, you swing in that direction. And the amazing part is that when it swings in that direction, it gets disconnected from the electric circuit, because remember I said the lower end is resting in Mercury. It's not really connected or locked down, it's resting in the Mercury. So when it swings away from the magnet, the circuit gets disconnected and current stops flowing, and then it swings back in. So it's kind of like swinging back and forth. Okay, I'll stop here for now. This is going to continue into part 2, where what is the purpose of all this?